So today's agenda, I'm going to pick up where we left off last time. I want to do a little bit more work on binary data and command line arguments. And then we're going to get into classes. And we're going to start actually designing a little video game. So binary data. This is a topic that we're covering in the files module. And so there's something that I went through very quickly that I want to spend a moment of time on. So what that thing is, let's see if I can bring up an alternate program here. This thing that's flashing on the screen, what is that thing? What's that called? Cursor. Yeah, it's not a trick question. So like here, if I start writing, right, if I don't hit enter, where does the next thing go? Right next to the E, right? So it's E cat, right? But if I hit enter, which is the same as hitting /n, we go onto that new line there. So here, and then I hit enter again, and I go here, right? So that same metaphor applies when we're dealing with files. So files have a thing called a cursor. And so when we open a file, in this case, I'm opening a file. What does this mode be? WB plus.
Right binary.
What's that?
Right binary.
Right binary and the plus part?
You can read or write.
Means I can read. Yeah. So in this particular case, since it's a W, this file, file.bin, is going to be created from scratch, or it's going to truncate the file if it exists. So here, I end up with file.bin, and the cursor is pointing at byte 0. Not necessarily line 0, but it is line 0, but byte 0. So inside that context manager, when I say file, this is the file object. Not this. I see something making that mistake. It's this thing. File.write, and I put those contents there. It ends up in the file, and the cursor moves to what looks like the next line. Technically, it is because I put this /n here. But this is at some byte. I don't know, byte 53, whatever. You may have seen this function seek. What seek does is it tells the cursor, go to that byte. The one we're really concerned about is byte 0. So we move the cursor to the top of that file. Why did I do that? In this particular mode, I'm writing to the file, and I'm also reading to the file. So if I had left my cursor here and I said read the file, read is going to start here. It's going to say, I don't have any data. But if I move the cursor here, it reads everything in the file to the end. That cursor only moves when I read, when I write, when I seek, when I read line, when I write lines, when I, any of those functions that we learned. When I say print line, the cursor stays there. And in this particular case, I just print out to the screen what was in that file. Now, if I write another line, if you saw what happened there a little quickly, when I write that line, it writes and the cursor moves to the next byte. Because I have a /n, it's ostensibly on the next line. Here, I seek again. I seek 0, then I go to the top of my file. And now I read. The cursor moves all the way down to the bottom. And the entire contents of that file now lives in that data string. And if I print it out to the screen, notice here that first print resulted in printing that first line. But here, I printed both the first line and the second line. And the reason is that cursor, or the read function, right, reads the entire file. So the cursor knows from all the way to the end. Right, so you can play with that a little bit on your own. Let's jump into EdStem and look at a couple of things related to binary files. So over here in EdStem, I took a screenshot just of the MCAT, I don't know, computer science website. This is what came up. Just took a screenshot. It's a BMP file, the type of image file. So there is nothing magical, really, about a binary file. So if I want to open it up in read mode, I say with open, right? Give the name of my file, read binary mode, and then I say read. So if I run this up, I get a whole bunch of these values. I could read 100 bytes, right? Relative to what I was talking about last time about hex, notice what I'm doing here. I'm converting that string into hex. If I take that off there, right, that's where you're going to start seeing this /x that the Zybooks material talked about. That's the hex code representation of that like 0 or 1 that you saw a minute ago. So here we see things like 0C, C3, 0E, stuff like that. But if you're trying to manipulate this file, I mean, unless you're really in that space, I'm not sure how you can interpret that and what to do. So if I want to muck about with files a little bit, right? In this example, let's say I want to copy that robot.bmp into a different file. So what would I do? Well, I need 2 files in this situation. With open robot.bmp, and I say read binary, I'm going to read all the contents into context. That's going to be basically a string, just a great big string that's actually taking up a lot of memory. Then I'm going to say with open robot-out.bmp wb. So it's going to create that file on the fly. So I'm going to take all those bytes and write them out. So if we look at that, that thing had a little under 3 million bytes, and it produced that robot.bmp file. And if I open it up here, it should look the same. Okay, so that's a very easy way to do file manipulation, right? I'm opening a file and copying it. Now, what would have happened if that file was like 10 gigabytes? What if it was a video? Would that have worked? Yeah, I'll tell you what, it probably wouldn't work. You probably wouldn't have enough RAM to hold an entire video file. So what you typically end up doing when you're going to copy a file or big data like that, and generally this is how networking works. You read a byte, you write a byte. You read a byte, you write a byte. Usually you optimize it, you fine tune it, and you say, I'm going to read 100 bytes, or read 100, write 100. Read 1,000, write 1,000, stuff like that. So if we look at this, there's a little enhancement to that syntax we know about the context manager. Notice here I say with open robot.bmp or read as in file. Then I say comma open this file. The advantage of this is, again, at the end, both of those will be closed for me. Like the memory will be cleaned up for me. So in here, hopefully you can all decipher this. I have a loop. I read the first byte, and I say while it's B. So that means it's not the end of file marker. So while it's true, basically, read a byte, write a byte, read the next one, and do this. This is going to do that 2,934,000 times. But it'll work. There's my next file. So again, no real magic here. What do you need to take from this, like for exams and stuff? Honestly, this is for just like a little bit of an appreciation. I'm not going to have you manipulate files on the quizzes and exams. But if you're doing some pet projects or you're playing around, this is where stuff is kind of cool. It's not just like text on the screen. You're actually doing some images. Okay. John's here. So, I was asked the question the last time we were in class, hey, if I have a file and I want to change like a byte in the middle, right? So I have like a 10 gigabyte file and I want to change 3 in the middle. You really can't do that. What you would have to do is you have to like read your file to the middle, copy it into a temp file, make your changes, put them in a temp file, and then continue reading your file. Really kind of annoying. So I'm going to demonstrate here where I'm going to open up these two files again, right? And I just picked a random byte here. Byte 1,200,1234567. Put it that way. Randomly. I randomly picked the byte. And I'm going to say, while I'm going through my loop, right? And I've seen people starting to use this syntax for an if statement. So it's just like that reverse backwards, like with open as in file. Another way to do an if statement or a branch. The thing I want to occur in my if, I can say byte 1 if current byte equals this. So this gets returned if this is true. Else, just read another byte. So I picked this random byte out there, and I'm going to change it to 1. So this time, here's my file. Let me open this up. Check out what happened. Basically, I corrupted my file. So I read all my bytes, and I just changed 1. And basically, at this point in time, whatever this paint program is that opened it up is like, wait a minute. I was expecting byte 7 or byte 8 or byte 9. So it just stopped. It's like, that's all I know. Now, I intentionally used a BMP file. Let me take another little change. Let me just make it to 12356. And hopefully we'll see that. Maybe it just gets totally jacked up there. Let's see. Yeah, it only got bytes up to that point in the file. I picked a BMP file because they're a little bit more susceptible to problems. You can corrupt them pretty easy. You end up with garbage like this. If I tried to do this with like a JPEG or a PNG file, you get like nothing. Because there's usually something called a checksum at the end that just says, hey, every byte has to be correct. BMPs don't have that. All right, so all that leads me up to the following. When you're going to deal with things like images, you're not going to be doing this raw file stuff. You're going to end up using different modules. So this is the Pillow module, PIL. There's a higher level construct for a class, which I hope to start today on the concept of classes. There's a class called image. And I can do something like image.open. Well, that opens a file, much like the way y'all learned how to do it here. Here's some fun stuff with that hex and RGB. So there's this higher level function here where I can basically take that image and draw a layer on top of it. So I'm creating a new image here with RGBA. Anybody know what RGBA might stand for? The color codes. A is kind of a new one here. It's called alpha. It tells you how transparent you want that image to be. So 0 means it's completely see-through. 255 means it's a solid wall of red, green, blue. So here, I set this to 00255. RGB, well, B is the 255. So this should take that same image, and when I run this up, it gives me an image that's now bluish. Got a bluish hue to it, right? And I can diddle that a little bit. Maybe I can make it more blue. I'll make the alpha 128. And in fact, while I'm in here, let me just make it green. So open that guy up. That same image is kind of green, right? And this is kind of neat. You can start mucking around with your own files. You start painting on top of it, right? So if anybody wants to play with that, it's a Pillow library. But more importantly, understand I have this thing called a class called image. It has a method or a function called alpha composite, right? So what I'm doing, I'm saying, hey, I created a new image that's sort of, in this case, green. Combine it with my existing image. And then print it out. So yeah.
Could you use that to overlay two image files on top of each other?
Yep. You can take two images. So if you had one image that had like a transparent background, you can superimpose it on top of the other one. Yes. If you had an image where it's like its background was like all black or all white, you wouldn't be able to see through it. So that image would have to have like an alpha of 0. Okay, I'm not going to go back to the deck because the deck is going to take us back into here. We're going to jump into the next and final topic, which is the command line. So normally when you see, people hacking around on TV and encoders, they are not using something like EdStem. They're not using something like PyCharm. They're using a terminal or a command line. And so usually, and this is a variant of Linux that's actually here. You can play with this in EdStem. In fact, you probably should start playing with it. There's a bunch of folks here in the hackathon today. I know they're doing this at the command line. So what is this topic, the command line? Well, it's also called system arguments or sysargv. And again, I've seen some people using this, whether they do it or not. But there is a module called sys. So if I say import sys, get rid of this stuff here, I can say print sys.argv. When I run that on its own, I get something in square brackets. And what's something in square brackets? It's a list. So the thing in the list is the name of the Python file I'm running. At the terminal, if I want to run a Python program, I would say python3, the name of my file, main.py. So notice Python thinks that is an argument. I can pass multiple arguments. I can put A, I can put B, I put 1, 2, 3, I can put 1, 2, whatever. I put whatever I want here. And it will give me a list with everything that I typed. Right? Why is this useful? Most of the time when we're writing real programs, not like Mickey Mouse programs for the classroom, you don't have a human sitting there typing and giving you the information. Like in Xylab, you really don't have a human sitting there waiting to give you the file. So what you do is you pass into your program an argument, right? Much like you pass an argument into a function, right? You're passing an argument into your program. You're saying, hey, program, use this. Process this file. Run for this amount of time. Whatever the meaning of your arguments are. Now, don't get hung up with this. I feel like people might get a little confused with it. This is just a list. It's just a list. There's no magic here. It's just a list. So in some of the homeworks and assignment, you might be asked, how many arguments are you passed? Well, I can use the length function, right? When I run this here, whoops. When I run it in EdStem, I'm not passing any arguments. So I just get 1, which is the name of that file. But if I go down to the terminal, that I run it with however many I type there, now I get 5. If I want to get like the third thing in that list, sysargv2, that happened to be the letter V. If I wanted to get the fourth thing in that list, the letter number 1, 1, 2, 3. Okay? That's going to throw a little problem in EdStem here because in EdStem, I only have 1 argument. So here we would have to put some defensive code in where we would say something like if if length sysargv is less than 2, then don't read index 2 because there's not going to be anything there. You're going to get an error. That's all there is to the command line. There's a lot of other groovy stuff that Zybooks talks about with system and how you can make different detections, whether you're on a Windows machine or a Linux machine or a Mac machine. I have an appreciation for that, but we're not going to do too much with that in this class from this point forward. Okay, I am claiming success on chapter 8. So that's all we're going to cover in files. All right. We are now going to move on to classes. Classes is where we get to be very creative. All right, I used this metaphor early in class, and I try to stick to it, like early in the semester. I said my sort of goal here is you're gonna write novels. But first I gotta teach y'all letters, then I gotta teach you words, then sentences, then paragraphs, then chapters, then books. This is all that fundamental stuff before we get to books. So what do we know so far if we want to capture data? Integers, floats, strings, booleans, lists, tuples, dictionaries, sets. We know an awful lot of stuff. Side note, I do encourage folks, please look back at the previous assignments, this freebie stuff we do in class. I'm seeing an awful lot of people still struggling a bit with like dictionaries and sets and how to create them and how to access elements. Intentionally, those freebie things tell you, this is how you create a dictionary. This is how you access an element in a dictionary. This is how you update an element, things like that. So at this point, to do the projects, to do classes, you have to have a pretty firm grasp on this. So it would kind of be like if I asked you to start writing books, but you're still struggling with the alphabet. The book's not going to come out so good. Now, we've also started to use our intuition as to when we would use different types of data, right? And I think we saw with like the simple interest calculation, we started out using ints as money, but it really didn't help us when we had cents, so we added that in. We had a couple problems in Zybooks talking about time, right, where we had, you know, minutes and seconds and things like that. What I want to talk about now is I want to do a little brainstorming exercise. Let's say we were going to start to build a video game. So video games typically, RPGs, role-playing games, have characters, okay? So we're going to think about what attributes a character has. So what do I mean by that? If I was sitting up here, I wouldn't say to everybody, I'm at the thing with 2 legs and a gray rectangular top. What would I say? I'm sitting at a what? Table, right? It's a layer of abstraction. But your brain knows, well, this is a thing that has 2 legs and a rectangular top. You can make that association. But we don't go around saying that. Up until this point in this class, if I asked you to describe something, like think about what we did with a tuple. It was very difficult, right? Because we had to know index 1 is latitude, index 2 is longitude. Name tuples helped a little bit, but it was kind of a crappy tool. So I want to start doing higher level functions, okay? So take 3 minutes, get with some friends in here, 2 or 3. I want you to think about at a high level, we're going to have characters in an RPG. What are some attributes of a character? And I gave you a few prompts there. Their health, how strong they are, their defense. Go for it. Spend about 3 minutes.
Some type of heal, like healing, speed, something. All right, no, I'm just saying, like, I mean, nigga, I just start playing video.
Dog? I don't like the movie. I love the ball, dude. I know 360 for
Keep it exactly the same. Don't say. What are you doing? What are you looking at that? Like I'm saying, oh, bought it yesterday. Yeah, like heels.
Play the game. Yeah, that's deep.
So even like perks, you like random perks. They can get you. Say what? Oh, interacting.
Yeah, like
Interacting with
a range.
Oh, range.
What range? Yeah, yeah. Range on weapon. Like a knife that I got the same axe. All the basics. Already had damage. Already had damage.
Yeah, that comes with it. Something like RPG.
Yeah,
That's not really.
oh no, but it's a terrible. So different. Yeah, so that's not just like ability, but like actually looks at it.
Stamina.
Oh, perfect.
Because like when I think of RPG,
Oh no, that's not RPG. It is but like,
but it's yeah.
it's like the turn-based RPG. So, like
Like Terraria. That'll be
All
kind
right,
of.
folks, let's bring it back together. So, yeah, but I heard y'all talking like esports. That blows my mind that like you monetize that. Because that's a thing, right?
I mean, we have one.
So,
Yeah, we haven't before.
We have one on campus.
yeah, I know. Well, Sage, one of your TAs, esports left. So anyway, so with this exercise though, part of that was just to get your ideas flowing, right? And you probably, were drawing from your own experience with some video games. But again, this is what we as programmers end up doing. Like somebody gets a prompt. Someone says, I'm going to pay you money to build a video game. And they might have like a vague idea, but you have to bring to the table that association of, okay, how am I going to model? How am I going to code, a person character, right? I don't know if anybody thought of this, but like, don't like limit yourself to humans. Like maybe your character was a pet, maybe an animal or something like that, right? So that's where we get to be creative as programmers, make those suggestions. What I'm showing here, and we'll get to how this is accomplished, but this is our goal. This is what we're getting to. This is literally how you would instantiate a character called Woody that has a strength attribute, a health, a name, and a defense score. I mentioned to some people, our job here is not just nouns. These are all sort of nouns, but there's also verbs. What can the character do? I heard some people say like, okay, can this character pick up an axe? Or can this character, cross a river? Can this character swim? Can this character run, walk, things like that? So when we deal with classes, we're really talking about two things: a grouping of attributes, a grouping of nouns, and a grouping of verbs. These are functions. These are literally just functions. We just learned the functions concept. So attributes are things that hold data. That's all the basic stuff we learned: integers, floats, strings. Probably every attribute you came up with to describe your character, hopefully you can make a connection in your brain and say, okay, well, the thing needs a strength score. I'll probably use an integer, right? The thing needs a name. I'll probably use a string. But then there's the verbs. Those are, I use this term a couple of times, methods, right? But it's just a function. So this general concept in programming is called classes. And classes is not unique to Python. Classes exist in pretty much every programming language, most notably object-oriented programming languages. So as the name implies, object-oriented programming means I'm dealing with objects. I'm dealing with real-life constructs. The opposite end of the spectrum is functional programming languages. Python, to a degree, is a functional programming language. Y'all did an awful lot of work, and you never touched classes, right? But as you saw a moment ago, that images, that would be a nightmare to try to put a green overlay on top of my image, right? If I didn't have that pillow module in the image class. So what is the syntax for a class? At this point, it's like I'm just repeating myself because I kind of am. It's the same as you learned for branching. It is the same as you learned for loops. It is the same as you learned for functions. In fact, it's the same as you learned for functions because you put functions inside of classes. So when I want to declare a class, a character, a menu item, a book, a table, or a piece of furniture, whatever it is, I use the keyword class, and then whatever I want to call my thing. There are some very special methods or functions inside Python. The concept exists in other programming languages. They're called constructors. In Python, a constructor of a class is underscore underscore init underscore underscore. So every class has this function called init. There is some magic here. There's a very special variable called self. You as the programmer, when you call this function, you don't pass as a parameter self. The interpreter does it automatically for you. Classes are such an important concept. The interpreter goes, I got this. I know you're talking about this table, not that table. I know you're talking about this chair and not that chair. So it does it automatically. This is just a function. So it takes parameters. You can have ordered parameters. You can have parameters with defaults. You can, I think you can put args and quargs in there if you wanted to. And then we have attributes. And attributes are just those static: name, age, height, weight, strength, speed, whatever it is. When this function is called, you can just assign your variable or your attribute with what was passed in. We'll play with that a little bit. This is a fully syntactically valid definition of a character. Here is my constructor function, underscore underscore init. It takes a character name, a score, a strength score, and a defense score. I have other attributes in my character, like health. I don't let the human put that in. I let the programmer tell me what that is. Everybody gets 100. If I want to have a special behavior on my class, this character can introduce itself. Maybe the character could help someone else. Maybe the character could fight someone else, right? So I have these functions. Well, in this case, this function just prints out, hi, my name is whatever. This is a little bit special, self.name. Well, that's my name. When I was constructed, what was I given? What name was I given? And that's what we'll print out here. So again, yeah, nearly identical to a function. In fact, this is a function. Just like you wrote your own functions, and we talked about how you call the function, right? We talked about how did we call the length function? Well, the name of the function, len, open parentheses, if it took a parameter, the parameters. How did I print something? Print, open parentheses. You had to write a function, calculate total. How did you call it? Calculate total, open parentheses. So if I want to instantiate a character, what's actually happening is the interpreter is calling your init function. They do this just because they know you're going to be creating objects all over the place. It's going to look really ugly with all that garbage there. So you just give the name of your class, character, and whatever parameters go into it. This will instantiate two characters, and they now exist in your program. Carefully, you can get like a god complex doing this stuff sometimes. Okay, what's happening under the covers? Let's take a look. Let's go into Python through this. Okay, so this is pretty much what we just saw. I've defined my class called character. I have my constructor function that does some stuff. And I've defined a function called help. Help has this special parameter self. So when we have a method on a class, we always have to put self as the first parameter. Then I can put whatever I want. So in this particular case, the purpose of this method is one of my characters can help another one. What happens under the covers? Under the covers, I have a strength score. The other character has a strength score. So if I decide to help that character, however many points they need gets subtracted from my strength and gets added to their strength. Quick comment on functions, just because there were a lot of questions on the quiz or the assignment. If name equals underscore main, this stuff. Books, chapter 7, lab 7.18 is the first lab we did. Everybody kind of breezed through it. They're like, oh, I had to change multiplication and division. That wasn't the point of that lab. The point of that lab was to learn about this notation here. I saw far too many people take their functions and put them in here. That's not where they go. In some cases, that will work. When you ran your program locally, it works. But it will not work when I test your code. And that's explained in 7.18. It's because I don't care about what you do in here. I care what you do up here. So just like functions being declared outside of the main scope, my classes, my objects are up here. All right. So when we run this, what happens? So the interpreter starts here at the top of my file. Is it going? Notice it immediately skips all that stuff. It's like, right, just like with a function, me interpreter, I'm just storing away the fact that there's something called character that exists in the global scope, which means everybody has access to it. Every function, every other class, everybody has access to it. Here it is. It's the character class. It has two functions, edit and help. So my execution jumps down to here. It enters the code block. I'm going to create two characters, a character called Dan and a character called Roy. So when we go to create Dan, the constructor init gets called. So now Dan exists in this world. Now I'm going to create Roy. Same thing. The constructor, the same constructor, gets called. And now Roy exists. I have a strength of 10. Roy has a strength of 1. And print that out. Dan has strength 10. Roy has strength 1. How did I do that? This is my object, Dan.name. Roy.name. Kind of looks like that sys.rb. The same concept. When I want to access ostensibly a variable that exists on a class, I use my instance name, Dan.name. Well, how do I know what are available? Well, I can look at the code. So in Python, all the code's available. Downside of that, all the code is also executable at any time. Some of you who know other programming languages, like Java, they have the concept of private and protected. It's you as the programmer saying, nobody should call these functions but me. They can only be called when inside my class. That's not true in Python. If you wanted to later on here, I could have said Dan.__init__, pass myself and all this stuff, and it would execute that code. It would be nonsensical, but you could do it. So I created my characters. They have attributes. Here, I'm going to call my method on my class, Dan.help. Okay? That's no different than you created a list object at some point. So you had a list called myList, and you said .append. Same thing. You had a string object, and you said .isDigit. All that happened is there's a class called string out there. There's a method called isDigit. And there's some magic, there's some logic in there that somebody wrote. So here, I'm going to go into my help function. So the cursor goes up into this help function. It has a handle to the parameter self, the parameter other, and this, like whatever, it's an int or something. So self, look at what it pointed at. Self is pointing at Dan. Other is pointing at Roy. I decrement the amount of help Roy needs from me. and I increment the help on Roy. Then go ahead and just print it out. Dan is helping Roy. But hopefully you saw there, when I started this method, I had strength 10, Roy had strength 1. Roy wants 4 bits of help. My 10 became 6, Roy became 5. Now I exit. I want to print that stuff out. Same thing as before. You can see my strength changed, Roy's strength changed. So hopefully you can imagine now how you can write your own video game. Create a class called Warrior. Create a class called Lumberjack. Create a class called Baker. Create a class whatever. Give it its attributes. Give it some operations. And then, if you want to make it interactive just with the keyboard, you can ask someone to enter in. You know, like, what would you like to do right now? Have Roy fight Dan. Have Roy help Dan, right? And you can kill your characters and you can make your characters fly or whatever you want to do. You get really creative with this stuff. A quick note on style. When we have our functions, we normally do them in lowercase. We had underscores and all that groupy stuff. Classes are a slightly different animal. There's something, which is what it's actually called camel case. So when we create a class, we want to name it where the first letter of each word is capitalized. So if I just have an animal class, I would just say animal. But if I had something called movie metadata, I would capitalize the M and I'd capitalize the other M. Okay. I have goofy pictures of camels, but we'll skip that. Okay, so we're going to start this and then we'll pick this up on Monday. Create a class called menu item. So here's just another example for us. Class, menu item, colon. First thing, I need my constructor. Define underscore underscore init underscore underscore. I can pass in just myself. Oops. Now, I give myself a name, self.name. I'm basically this object, self, that's passed in. I'm saying self.name equals, yeah. Maybe I say self.age equals 47. Okay. Actually, bad example. I'm trying to use menu items. Let's say menu item is taco. And price is a float. Say this taco costs $4.50. So if I want to create this menu item equals menu item. If I say print menu item, I'm going to get some garbage. Name menu items object at blah, blah, blah. That doesn't help me very much, but I want to use that dot notation. I can say dot name. Maybe I do something like is, comma, menu item dot price. Oops. So taco is 4.5. Okay. If I wanted to pass some parameters, maybe here I want to pass name and price. So now I say name. And now I say price here. This becomes exponentially more valuable because now I don't have just that class that's bound to tacos. I can say this is a taco and this taco is $4.50. And I can say this item is a hot dog And it costs $5. I'll call this menu item 2. So taco is $4.50. Hot dog is $4.50. We're going to continue on with that in some great detail over quite a few classes. As mentioned, this is another one of those big chapters where I'm kind of like sucking in all different chapters. Today was roughly 9.1 through 9.6. Where does that leave us? So that leaves us here. Tonight, Lab 8 and Homework 8 are due. So please get on that. I moved the quiz. So because we just finished the file stuff today, the quiz on files won't be until Thursday. Okay. Remember, we have Wednesday off. Wednesday is Wellness Day. So get going on classes. We didn't get to the first one. Do the first one first. Assignment 8, like I said, is out there. That will be due next Friday. Right, y'all? Good weekend.